Hi scholars, today we're going to talk about how to problem solve with rates and units, and in particular we're going to talk about unit conversion. So for example, turning miles per hour into feet per second. Unit conversion traditionally is challenging for students, but really the sort of the procedure, the method that we use is based on two fundamental principles. So let's take a look at them. So the first says that if two values are the same, then the ratio of one to the other is equal to 1, right? And algebraically, we can represent this as if A equals B, right? It means A is the same thing as B. Then A over B is equal to 1, right? We can take this as a number. If 5 equals 5, which it does, then 5 over 5 is equal to 1, right? You can do it with any number you want, just to verify that this is indeed true. Second principle is if you multiply any value by 1, you don't change the value, and that's sort of one of the first things we learn, right? So x, any number times 1 is just equal to x, right? In fact, any number x, there's always that invisible coefficient, right, of 1 in front there, which is saying I have one of these things that are x. Okay, so this all seems very simple, so let's take a look at what that would look like when we're dealing with unit conversion. Example 1, a stick measures 30 inches. How many feet is this? So this is an example where we're being asked to convert inches into feet, okay, and this is our conversion. Now we could do this pretty easily. We know that there are 12 inches in 1 foot, so we know 12 inches equals 1 foot. These are the same things, right? This is the same as this, and so we could say, okay, so let's have 30 inches. I could do 30 divided by 12. That's going to equal 2.5, and so my answer is 2.5 feet. Okay, now that's just sort of reasoning about it. You could also have set up a proportion. You could have said 12 inches is 1 foot, so 30 inches is how many feet, right? And then cross-multiplied, you would have gotten the same answer. This is all fine. So we're going to introduce yet a third way of solving this problem, that in this particular problem, it may not seem like it's super useful. However, when problems of unit conversion get more complicated, it will be useful. So this is what we're going to do. We are starting with 30 inches. So the first thing I write is 30 inches. 30 inches. This is where we're starting with. We're going to do something, and we want to end up with feet. Okay, so this is our goal. Our goal is feet. Let's actually use a different color for that. So our goal is feet, and we're starting with 30 inches. Okay, and we know that 12 inches is equal to 1 foot. In other words, these are the same thing. So essentially what we're going to do is we're going to take 30 inches. We don't want to change the length, so we're going to multiply it by 1. You say, wait a minute, multiply it by 1, what are we doing here? This doesn't really change anything. Well, we're going to write 1 in a very particular way. We're going to write 1 as a ratio of 12 inches over 1 foot. And why can we do that? Because 12 inches equals 1 foot, right? This is like that principle we saw earlier. This is just saying that A is equal to B, right? We saw that earlier, that if A is equal to B, then A over B is equal to 1. Now, notice what we can do. We have the unit inches on the top and on the bottom, right? This 30 is nothing more than 30 over 1, so the inches is on the top, inches on the bottom. We can cancel the units of inches, just the same way we could cancel numbers if you had the same factor on the top and the bottom of a rational expression or of a fraction. And look what's left over. The very unit that we want, right? And look what's left over. The number 30 is left over on the top, so let's just copy it over. And the number 12 is left over on the bottom. Let's copy it over. And so in fact, your answer is exactly what we found over here, right? 30 over 12, otherwise known as 2.5 feet. Okay, so this is one way to, another way to do this unit conversion. So let's take a look at some examples where it's actually a little more useful to have this method, right, in our toolbox. Okay. Example 2. So a bee flies 22 feet every 3 seconds, and we want to know how many minutes would it take to fly 1 mile. Okay, so let's see what we're looking for, right? So we're going to do some math, and we want to end up with something that is a ratio where it's actually, in this case, minutes per mile, right? Per mile. So this is what we want to end up with. This is going to be a unit rate because we want to find minutes per 1 mile, right? And so let's see, we're given information about feet and seconds. And so I know seconds and minutes are both a measure of time. I know that feet and miles are both a measure of distance. So let's write that ratio over here. So we're starting with takes 3 seconds. So it's going to take 3 seconds. Seconds and minutes line up. They're both in the numerator position, the top position. And 22 feet, feet and miles, are both distance. So let's put that in the denominator position, right? In the bottom. Okay, 22 feet. So what we're going to do, just like we did before, is we're going to convert seconds per foot into minutes per mile. And we're going to do this by multiplying by, you guessed it, by 1, because we don't want to actually change the speed or what the bee is doing. We want to keep that the same. We just want to change the units. Now, of course, it doesn't make sense. I can't just multiply by 1 and then end up with minutes per mile when I have seconds per feet. So let's do it, right, in a smart way. So first off, let's convert seconds to minutes. So what's the relationship between seconds and minutes? Well, I know that 60 seconds is the same thing, is equal to 1 minute, which means that the ratio of 60 seconds over 1 minute, or the ratio of 1 minute over 60 seconds, is equal to 1, right? So the question is, which of these ratios do we want to use? Well, I have seconds right now on the top of the fraction in the numerator position. It would be really nice if I could have seconds in the denominator position here. So let's just do that, right? Let's say that we're actually going to multiply this by 60 seconds. And then in that case, the numerator position is going to be 1 minute, right? And now look at what happens. It's very nice because I have seconds on the top and the bottom, and just like you can cancel out common factors, you can cancel out units, right? This is another key principle of unit conversion. So notice when I cancel out seconds that was on the top and the bottom, what am I left with? I'm left with minutes, which is exactly what I want to end up with. That's super. Let's keep going. What do we need to do next? We need to convert feet into miles. Well, I know from either Googling it or it's also in your classwork that 5,280 feet is equal to 1 mile. So again, we have to ask ourselves, sorry, I'll just write mile. We have to ask ourselves, should feet, right, this unit be on the top or the bottom? Well, here we have feet already as a denominator on the bottom, so we want to put it on the top so we can cancel. So let's put 5,280 feet on the top, and on the bottom is 1 mile. Now I'm not multiplying by 5,280 here. I am multiplying by 1 because I'm not changing anything, right? These two things are the same. So if I make the ratio, right? If I tell you I ran 5,280 feet, or if I tell you I ran 1 mile, I'm not telling you different information, right? These two things are identical. That's really what the equal sign means. So we're not changing anything. We're just converting the units. Again, feet now on the bottom and the top I can cancel, and what am I left with? I'm left with miles, which is exactly what I want to do. And now it's pretty easy. You just pull out your calculator and you multiply all the numbers that are on the top, which is 3 times 1 times 5,280. You multiply all the numbers that are on the bottom, which is 22 times 60 times 1, right? You find that ratio, you divide this number by this number, and when you do that in your calculator, you will end up getting 12 minutes. So the bee flies in 1 mile. It takes the bee 12 minutes to fly that 1 mile. And that's sort of how you do this. Let's do one more example. Example 3, you're in a car traveling at a steady speed of 50 miles per hour. Okay, so we are given a speed 50 miles per hour. When you enter a tunnel, you hold your breath until you've come out the other side. If you held your breath for 8 seconds, how many feet long was the tunnel? Okay, so this is a question that we think, wait a minute, there's a lot going on here. This is a unit conversion question. I'm starting with my speed, which is 50 miles per 1 hour, right, per hour. And I want to say, what is that in feet per second, right? Because if I know my speed in feet per second, and I know that I held my breath for 8 seconds, right? I can easily find out how many feet that was, right? Because I know for 1 second, maybe it's 5 feet. So for 8 seconds, maybe it's 8 times 5 feet, right? 40 feet. So this will allow us to finally solve the answer, right? It's sort of a multi-step problem. So let's convert miles per hour into feet per second. We'll do it a little quicker here. So first step is, let's convert hours to seconds. Okay, so I know that there are 60 minutes in 1 hour, and I write it 60 minutes on the bottom as the denominator and 1 hour on the top, because what I want to do next is cancel the units of hours, right? And now I'm just left with minutes. I don't want minutes, I want seconds. So let's keep converting. I also know that in 1 minute, there are 60 seconds, okay? So again, I'm multiplying by 1, I'm multiplying by 1. The minutes now are on the top and the bottom. Let's cancel them out. And now, the unit that I have left, seconds, is exactly the unit that I want, seconds. That's super. So now let's just make sure that we can turn miles into feet. Well, we did that in the last problem, right? We know that there are 5,280 feet in 1 mile. So let's write 5,280 feet over 1 mile. And let's cancel. Oh, wait a minute. I can't cancel here. I have miles on the top and I have feet on the bottom, right? So I must have done it the wrong way. So let's rewrite it, right? Let's, instead of putting 5,280 feet on the bottom, let's put 5,280 feet on the top is 1 mile on the bottom. And now I can cancel. That's good, because now I have the same thing on the top and the bottom. And what am I left with? Well, I'm left with feet per second, and I want to have feet per second. That's super. And we do the math, and we get about 73.3 feet per second. And of course, we're not done yet, because you held your breath for 8 seconds, right? So every 1 second, you pass 73.3 feet. So in 8 seconds, how far did you go, right? That's the question. So we can do that pretty easily by just doing 73.3 times 8, which is going to give you about 586.4 feet. And that is your final answer. So that's how long the time is.